it, that's cleanup. The T26e3 heavy tank. Big though it is, it has the sleek look of a giant greyhound. This is partly due to its sloping V-shaped front, and partly to the very low silhouette, which makes it a difficult target to hit. It has no trouble at all with rough terrain. It climbs any grade up to 60%. It crosses trenches as wide as 8 feet. Thanks to the fact that it has torsion bar suspension, it can overcome 46-inch obstacles. It's a lot of tank to do stunts like these. 45 tons to get down to statistics. Its turret is cast armor steel, and its hull is heavy armor plate. It can take plenty. It can dish it out, too. In fact, that 90mm gun is the most potent weapon that we've ever mounted in a tank. In addition, there's a caliber 30 machine gun mounted in the bow. Another caliber 30 is mounted coaxially in the turret. And a caliber 50 is mounted up on top. Now we'll strip away the fenders and sand shield so that we can look over the track and wheels and the torsion bar suspension that helps the tank over the bumps. The 6 dual rubber wheels are the same type as those on the light tank M24. Each wheel is divided in 2 sections, the channel between accommodating center guides that help keep the track in place. Up here, the track is supported by 5 track support rollers. Each of these rollers has a lubrication fitting, right here. The rollers must be greased immediately after contact with water or mud. Otherwise, the bearings will freeze and lock the rollers. If the rollers do not turn when the track goes over them, there'll be trouble. To maintain track tension, there is a compensator wheel mounted on either side at the front. The compensator wheels keep the tracks tight even when going over an obstacle. They work this way. A bar connects the compensator wheel spindle to the front road wheel. When the front road wheel is lifted, the bar moves the compensator wheel forward, taking up the slack. Here's the way it works with the wheels and track on. The tracks themselves are a little different from anything we've ever had on a tank before. They're all metal and 2 feet wide. The track tension must be checked at least once each week. To do this, the tank must first be allowed to coast to a halt without using the brakes. Then, using a pry bar, install 1-inch spacers between the track and the 2nd and 4th support rollers. There should be blocks on both inner and outer rollers. Measure the clearance between the 3rd roller and the track. If the track tension is correct, this clearance should be 1/4 inch. To make any necessary adjustment, the front fender and dust shield must be off. Then remove this cotter pin. Using the open-end wrench, back off the lock nut. Use the adjuster spanner wrench to move the adjuster. The adjuster will be moved forward if tension is to be tightened, backward if it is to be loosened. If you want to break tracks, it calls for special tools. 2 track connecting fixtures, a drip, 2 bushing pullers, a bucking tool, a hammer, a pry bar, and a track pin wrench. Drift and bucking tool are used when a track pin removing tool is not available. First, the track connecting fixtures must be attached and tightened enough to take the tension off the track pin. Normally, they can be tightened sufficiently by hand. Then remove the track pin nut and washer. Here is the special track pin removing tool. Hook it into the sprocket holes on either side of the track pin to be removed, and tighten it in place. Then the track pin can be driven out without difficulty. The need for the bushing pullers becomes clear when a couple of disassembled track links are examined. Each track link has 5 bushings, 3 on one side, 2 on the other. The bushings are serrated on the ends, and when the links are together, the serrations are engaged. Thus, the bushings become one unit after the track pin is installed. To disengage the serrations, the bushing pullers are used. Insert a puller inside the bushing and tighten the screw. Then turn the puller nut. This separates the bushings. Here's the same thing being done on the vehicle. When the 2 outer bushings have been withdrawn enough to allow clearance for the serrations, take off one of the track connecting fixtures. Now the loosened track must be supported by a heavy bar so as not to damage the bushing serrations. Then the other track connecting fixture can be detached and removal of the... This is the front road wheel lifting tool. It takes a lot of the sweat out of installing a new front road wheel. One end goes against the hub of the road wheel, the short prong up. The other end is set into a sprocket hole forward of the wheel in this fashion. Driving the tank forward slowly will raise the wheel from the track so that it clears the center guide. This other lifting tool performs the same function for the remaining road wheels. The hole in the end fits over the spindle extension of the wheel. The other end is placed in a sprocket hole forward of the wheel. As the tank is driven slowly forward, the wheel is raised clear of the center guide. This tank has a rear drive, so the sprocket wheels are back here. The sprocket teeth fit into holes in the track. Now let's see how the engine drives the track. These doors provide easy access to the engine and powertrain. The engine, torque-matic transmission, and differential can be lifted out as one unit. Tracing the powertrain backwards from the sprocket wheels, we come to the differential here in the rear of the compartment. The torque-matic transmission acts as both a clutch and a variable transmission, eliminating the clutch pedal and cutting gear shifting to a minimum. Differential and transmission are bolted together. The engine itself is a liquid-cooled 8-cylinder V-type of 500 horsepower. Now we'll lower the cooling unit into place. A word of warning about this unit. Engine oil may splash onto the cores, and when mixed with dust may plug up the air spaces. Keep these radiator cores free from oil to prevent overheating. On the right rear of the unit are 2 differential oil coolers. On the left are 2 transmission oil coolers. In front of the oil coolers are two engine radiators, and the whole unit is cooled by these 4 fans. There are 2 gas tanks, one on either side of the engine. Together they hold about 185 gallons. Each has its own filler. The radiator filler is over here beneath this armored shield. The cap must be securely tightened against this seal because the engine uses a pressure cooling system, and if the cap is not tight, the resulting loss of water will cause engine failure. Now let's get ready for a ride. The gunner's hatch has coil springs which make the door easy to open and close. The tank commander's cupola has a torsion spring which serves the same purpose. The cupola has 6 vision blocks as well as a revolving periscope, so the tank commander can look directly out when his door is closed. Now we're in the fighting compartment. Take a look around. The bustle in the rear of the turret acts as a counterweight for the 90mm gun. Furthermore, it's a handy stowage space for a large radio, interphone system, and small arms ammunition. Also accessible from the fighting compartment are the air filters for the carburetors on the main engine. These are designed to take air either from the fighting compartment or from outside the tank. It's no longer necessary to leave the protection of the turret in order to clean the filters. This is an important new feature because these filters must be cleaned at least once daily and as often as every 4 hours in dusty terrain. A few years ago, no one thought a 90mm gun could be mounted in a tank. But Ordnance Ingenuity developed a hydrospring recoil mechanism, and that's made the use of this big gun possible. Recoil is cut down to a minimum by this mechanism, with an assist from the muzzle brake on the tube. The turret is traversed by an oil gear system, which requires an electric motor. This means that when the tank is used as stationary artillery, a source of electricity is needed for the power traverse. An auxiliary engine on the right of the tank engine drives a generator which supplies the electricity needed. The auxiliary engine has its own starter, which can be reached from the fighting compartment. Here it is. The turret lock must be released before the traversing mechanism is operated. To start the electric traversing motor, this switch on the right of the 90mm gun must be in the on position. Next to it is the firing switch. This is the gunner's power traverse control handle. This is the tank commander's traversing lever, which at any time can take the control of the power traverse away from the gunner. The turret can also be traversed by hand. But this is much slower than the power traverse.